Hello students, welcome to Hers International School YouTube channel, and today we will discuss about polynomial. Since polynomial is a type of algebraic expression, that's why we had discussed about algebraic expression in previous lecture, and today we will discuss about polynomial. Okay, so without any delay, let's get started. So first question is, what is a polynomial? So a polynomial is an algebraic expression in which power of the variable is a whole number, or we can say exponent of the variable is whole number, and whole number start from 0. Okay, whole number start from 0. Check the first example, which is 4x plus 2, and it consists two terms. First is 4x, which is a variable term, and second is 2, which is a constant term, and the power of the variable is 1, and 1 is a whole number, so we can say 4x plus 2 is a polynomial, and this algebra or this polynomial consists only one variable, so we can say it is a polynomial in one variable. Now second example is 2y square minus 3y plus root 2. The power of the variable of first term is power of the variable in first term is 2, and power of the variable in second term is 1. Okay, both 1 and 2 are whole number, so we can say 2y square minus 3y plus root 2 is a polynomial in one variable. Clear? Third example, 2x cube minus 3y square plus root 2. So power of the variable in first term is 3, power of the variable in second term 2. Both 2 and 3 are whole number, so we can say 2x cube minus 3y square plus root 2 is a polynomial in two variable. Why in two variable? Because it consists two variables. First is x, second is y. Clear? Now third example, 3 by x, and remember one thing, in polynomial the variable should be with the numerator, so we have to transfer this x, this variable, to with the numerator. So instead of 3x, we can 3 by x, we can write 3x raised to power minus 1, and minus 1 is not a whole number, so we can say 3 by x is not a polynomial. Next example is 5x square plus 2 root x, and it consists two terms, both variable terms. First in first term, power of the variable is 2, and in second term, power of the variable is 1 by 2, because instead of root x we can write x raised to power 1 by 2. So power of the variable of second term is 1 by 2. Since 2 is the whole number but 1 by 2 is not a whole number, so 5x is to power x square plus 2 root x is not a polynomial. Clear? Next point is degree of the polynomial. So degree is the highest power or highest exponent of the variable. Clear? So example, check the example, 4x plus 5 cube, 4x plus 5 cube. Can you tell me the degree of this polynomial? Degree of this polynomial is 1, because it consists only one variable and its power is 1. And remember one thing, you have to check the power of the variable only, no need to check the power of the constant. Second example, power of the variable in first term 2, power of the variable in second term is 1. 2 is greater, so 2 is the degree of the polynomial. Clear? Next point is type of polynomial. Polynomials can classify on two bases. First, on the basis of number of term, and second on the basis of number of degree, or we can say on the basis of degree. So first we will talk about type of polynomial on the basis of terms, number of terms. First is monomial. So what is monomial? A polynomial of one term. A polynomial of one term is called monomial. Check this example 40. It consists only one term, so it is a monomial. Second, binomial. A polynomial of two term is called binomial. Check this example 40 plus 2 and it consists only two terms, so it is a binomial. Similarly 2p plus 7 consists two terms, so it is also a binomial. 9x square plus 4 is a binomial because it consists two terms. Next is trinomial. A polynomial of three terms is called a trinomial. 9x square plus 4x plus 9 is a trinomial because it consists three terms. First is 9x square, second term is 4x, and third term is 9. Terms are separated by plus or minus sign. Clear? Next, type of polynomial on the basis of degree. First is linear polynomial. A polynomial of degree 1. A polynomial of degree 1 is called a linear polynomial. It's called a linear polynomial. An example is 40 plus 3. 40 plus 3 and its degree is 1, so it is a linear polynomial. 2p is also a linear polynomial, and general form of the linear polynomial is ax plus b, where a and b are real numbers. Okay, and a is not equal to 0. Why a is not equal to 0? Because if a becomes 0, then the first term becomes 0. Then only b left. B means what? Instead of b we can write b x is to power 0 and its degree is 0. Okay, and its degree is 0 and it become a constant polynomial. Clear? So a is not equals to 0. This is the condition for the linear polynomial. Next, quadratic polynomial. A polynomial of degree 2 is called quadratic polynomial. Example 2p square, because degree of 2p square is 2, so it is a quadratic polynomial. 9x square plus 4, degree of 9x square plus 4 is 2, so it is a quadratic polynomial, and its general form is ax square plus bx plus c, where a, b and c are real numbers and a is not equal to 0. A is not equals to 0 because if a becomes 0, then this term becomes 0. Then what left? Bx plus c, and bx plus c is a linear polynomial, not a quadratic polynomial. Clear? So this is the condition for quadratic polynomial. Next, cubic polynomial. A cubic polynomial of degree 3 is called cubic polynomial. A polynomial of degree 3 is called a cubic polynomial, and its example 2p cube. 2p cube because its degree is 3, so 2p cube is a cubic polynomial. 9x cube. 9x cube plus 4x is also a cubic polynomial because its degree is 3. Degree is the highest power of the variable. Clear? And its general form is ax cube plus bx square plus cx plus d, where a, b, c and d are real numbers and a is not equal to 0. Clear? Why is not a is not equal to 0? Because if a becomes 0, then the first term becomes 0. Then what left? Bx square plus cx plus d. Then it will be a quadratic polynomial, not a cubic polynomial. That's why a is not equal to 0. Next is biquadratic polynomial. A polynomial of degree 4 is called biquadratic, and its general form is ax is to power 4 plus bx cube plus 6x square plus dx plus e, where a, b, c, d and e are real numbers and a is not equal to 0. Clear? Next is constant polynomial. Constant polynomial. A polynomial of degree 0. A polynomial of degree 0 is called a constant polynomial. Clear? Like 2, 9, root 2 are constant polynomials. Clear? Because its degree is 0, because instead of 2 we can write 2x is to power 0, and 2x is to power 0 means 2 only. Clear? So its degree is 0, that's why it is called a constant polynomial. Next is zero polynomial. Number 0 itself is known as zeros polynomial, and its degree is not defined, because instead of 0 we can write x multiply x, 0 multiply x square. 0 multiply x square means 0 only. So it's clear. Or instead of 0 we can write 0 multiply x cube. Clear? Because 0 multiply x cube is 0 only, that's why its degree is not defined. So that is it for today, and in next lecture we will start 2.1, exercise 2.1. So thank you.